Hi, welcome back to my channel. This is the video still showing the area of a region by integration. So here I got the question 9 because previous I have 2 videos that I recorded previously is about the question 1 to question 8. Now we continue the question 9. Calculate the area of the region by curve. This is the quadratic curve, the x-axis, the y-axis, and the line x equals to 1. To find the area of the region, we need to sketch the curve first. First, I will have my x-axis and y-axis. And we can see that our function given here is already in the completing square form. And we can directly get the minimum point or maximum point from this form. So just look at the coefficient of this is a positive. So we know that the shape will be minimum, having the minimum point. Or we say the open upwards, the quadratic, the parabola which is open upwards. Then what is the minimum point over here? We will look at this value. X minus 1 we equate it to 0. We have x equals to 1, meaning that the x coordinate of the minimum point will be 1, and the y coordinate, just take the 2 in, we have a 2. So we are going to sketch this curve on our axis, where the minimum point is at 1, 2. So I'll try to figure out where is your 1, 2. And it's roughly here. So I just sketch a quadratic curve. Passes through this point and go up. You can label this curve as a y equals to x minus 1 square plus 2. Alright, so now we are going to get the area of the region by this bounded by this curve. The x-axis, which is this is the x-axis, the y-axis, and the line x equals to 1. Basically, you are actually finding this area. Okay, this area which is bounded by the curve, x-axis, y-axis, and the x equals to 1. So to get this area, again, we need to integrate. We need to integrate because this area, we can see that the area is 4 above the x-axis, so we do not have to put the modulus. We just integrate as usual, integrate from 0 to 1. Why 0? Because this is a 0, this is the lower limit of the region, and this is upper limit. The 1 is upper limit. So we integrate from 0 to 1, and this area or this region is bounded by this curve, so we put in the curve. Before we put in this curve, I will suggest that you might trying to expand it first. It's easier for us to integrate. Alright, expand this. You have a x squared minus 2x plus 1 plus 3. You got a plus 4. Let's check. X squared minus 2x plus 1 plus 2. Alright. Sorry, should be 3. Alright, this one is 3. Just put in the expanded form inside. We have a x squared minus 2x plus 3. Integrate with respect to x. You have a x cubed over 3 minus 2x squared over 2 plus 3x. We can see that the 2 over here can be simplified. Just simplify. Okay, cancel off the 2 and put in your lower limit and upper limit. Then after that, you are preparing for the substitution of the upper limit and minus substitution of the lower limit. Substitute upper limit 1 inside, you have a 1 over 3 minus 1 plus 3. Substitute lower limit, you got 0. Then we can calculate for the final answer. You will have a 7 over 3 units squared. Now we move to the second question, question 10. Find the area of the region bounded by the curve y equals to 2x cubed. Now we are actually just question before this, we are dealing with the quadratic function. Now we are dealing with the cubic function. And now the area is region is bounded by the curve. The line y equals to 2 and y equals to 5 and y-axis. So by hook by crook, you have to sketch the diagram. Alright. You have your x-axis, y-axis, and I'm going to sketch the y equals to 2x cubed. Basically, we know how to sketch the y equals to x cubed. If your x cube multiplied by 2, it won't affect the shape of the graph. It just affect the gradient. Maybe you will see that the graph is going faster, okay, going up faster or going down faster. All right, so we'll follow back the shape of the y equals to x cube. The shape is roughly like that. Okay, from here, from the first quadrant, you go to the third quadrant, and it passes through the origin. All right, so this is a y equals to 2x cubed. And now trying to figure out where is the region the question asking for. We have the line y equals to 2. Y equals to 2, maybe you will say that this is a y equals to 2. And y equals to 5 somewhere here. So just label it. This is 2 and 5. And the y-axis. So actually, the area that the question means is this one. Okay, you are going to get this area. How do you get this area? Because this area is attached to the y-axis. We are going to integrate with respect to y, and the limit is also at the y-axis. So according to the formula, the area is equals to integrate from the a to b, and since we are having the area bounded by the y-axis, so we are going to integrate with respect to y and taking the function of the fy into your integral, meaning that you need to get the x in terms of y. What you have here is y in terms of x. So to integrate, you need to get the x in terms of y, meaning that you have a y over 2, get your x as a subject, you get x cubed equals to y over 2, and the x will be equals to cube root of y over 2, or you may write as y over 2 to the power of 1 over 3. So we are going to use this function in terms of y put into our integral, and the limit is from 2 to 5. The function will be y over 2 to the power of 1 over 3. Now we're going to integrate with respect to y. So you have the coefficient. You can see that this is a y power of 1 over 3. And down here you get the 2 power of 1 over 3. So 2 power of 1 over 3, you can take it out if you want. Okay, if you want, you can take it out. You have a 2 power of 1 over 3, or we say that is a 1 over cube root of 2. And integrate y power of 1 over 3 with respect to y from 2 to 5. 2 to 5. Now we start to integrate, and the coefficient always remain outside. Integrate y power of 1 over 3, you get y power of 4 over 3 over 4 over 3 over 3. The 3 you can bring up here. You get 3y power of 4 over 3 over 4 from 2 to 5. Now you can see that another coefficient is 3 over 4. If you want to take it out, also can, no problem. You can take out the 3 outside, and then you have a 4 multiplied by cube root of 2. Alright, then in the bracket, you just left y power of 4 over 3. Substitute the upper limit, you have a 5 power of 4 over 3, minus substitute the lower limit, you get a 2 power of 4 over 3. Probably for these answers, you better leave it in the form of a decimal, because we can see that so many number that you have a cube root here, you get a cube root inside here. So you can use calculator to help you to get the final answer. Alright, you will have the answer 3.5895. Or you may give a 3 significant figure, that is 3.59 unit square. Right, this is the answer. Next, we shall move to the question 11. Find the area of the shaded region enclosed by the curve 8x cubed plus 1, the x-axis, x equals to -1 and 1. So again, first we have to worry about how to sketch the graph. Again, firstly, you must have your x-axis and the y-axis. And now you need to sketch the 8x cubed plus 1. We know the x cubed graph will be like that. start from the first quadrant, go to the third quadrant. This is a y equals to x cubed, where it passes through the origin. So if you have 8x cubed, it won't affect the shape, but it will go a bit faster, go up faster, and go down faster. That will be the y equals to 8x cubed. Then if you have an 8x cubed plus 1, meaning that now you will change the location. The 8x cubed, alright, will move, all the graph, all the point on the graph will move up 1 unit because of the plus 1. It will move up 1 unit, meaning that you can refer to the points of the origin. Okay, originally it passes through the origin, so now this point is moved up 1 unit. It will become like that. The shape still will be the same, but the location has changed. It moved up 1 unit. So it become the y-intercept will become 0, 1. And now you can label the graph as 8x cubed plus 1. So figure out where is the region that they are asking for. You want the curve with the region which is bounded by the curve, the x-axis, the line x equals to -1. Alright, so now is including the, you need to sketch a graph of the x equals to -1. So you must know where is this point. Is the -1 is at the left hand side or right hand side? You need to be very sure. So we need to know where is this point. So how do you get the x-intercept? You just substitute y equals to 0. Substitute y equals to 0. You have x cubed equals to -1/8. Alright, x equals to cube root of -1/8. That will be -1/2. So obviously this point is -1/2. The x-intercept is -1/2. Now x equals to -1. Now you can be sure that you need to sketch x equals to -1 somewhere at the left hand side of the -1/2. So you are getting the area from the -1/2 to from -1 to 1. Alright, so now figure out where is the region you are going to shade. That will be this region and this region. So you can see that the region that we shade, including the region above the x-axis, which is I label it as a P, then this region as a Q. So I need to find the region A, the area of the P and area of the Q, then only I can sum them up. Alright, so get the area of the region P first. Area of the P, okay, since the area of the P, the region of the P is 4 above the x-axis, so you do not need to put a modulus. You just integrate as usual. Integrate from -1/2 to 1. And then the function is the 8x cubed plus 1. Alright, then just integrate. I have integrated and simplify. I get this. Now we are going to substitute the upper limit and the lower limit. After the substitution, you have this. So now with the assist of calculator, calculate the final answer. Here I got 27/8. So P, I got it 27/8 unit square. So now I'm going to get the area of the Q. Since the area of the Q is 4 below the x-axis, I need to put a modulus. So every operation integral, I will do it inside this modulus. I'm going to integrate from -1 to -1/2. The same function will be applied and integrate as usual. Integrate, you have this. So now we're going to substitute value. Okay, so this is a negative. After you simplify, you get a -11/8. And the modulus will convert it back into the positive 11/8 unit square. So the total area is the area of P plus area of Q. We just add them up. That will be 11/8 plus 27/8. And simplify, the answer should be 19/4 unit square.